In the late 1960s, a paleontological expedition worked the shores of Lake Turkana in northern Kenya. The sediment they were excavating was ancient, between 5.3 and 1.8 million years old. Pliocene and Pleistocene deposits. They found skulls, crocodile skulls, massive ones. At first, the researchers assumed they'd found an unusually large Nile crocodile. Modern Nile crocodiles can reach impressive sizes, up to 16 feet, occasionally larger. But as they excavated further, the scale became clear. These weren't Nile crocodiles. The skulls were as large as the biggest saltwater crocodile skulls ever recorded, and they were extinct. The species was named Crocodylus thorbjarnarsoni, and when paleontologists reconstructed its size from the fossil evidence, they realized something unsettling. This was likely the largest true crocodile that ever existed, and it lived alongside early humans. Modern saltwater crocodiles, the largest living reptiles, reach about 20 feet in length and weigh just over a ton. They're apex predators, feared throughout their range in Southeast Asia and Northern Australia. Crocodylus thorbjarnarsoni was substantially larger. Conservative estimates place it at 25 feet in length. Some specimens suggest 27 feet. Weight estimates exceed 2.5 tons, larger than an average hippopotamus. And here's the problem with fossil estimates. They're based on bone measurements that typically underestimate maximum size. The largest individuals, the ones that lived longest, grew largest, are rarely preserved. Only 9 specimens have been recovered, which means the largest individuals almost certainly remain undiscovered. The anatomy tells the story. Thick, bony plates along the back and sides, armored like a tank. Jaw structure indicating crushing bite force, one of the most powerful biters on Earth during its time. Not built for speed, built for ambush, built for overwhelming force. 5 million years ago, the Lake Turkana region looked different. The area was covered by expansive deep lakes and river systems, fresh water, stable climate, abundant prey, and early hominins lived there. Multiple genera occupied the region simultaneously. Australopithecus, Kenyanthropus, Paranthropus, Homo habilis, Homo rudolfensis. Different species, different ecological niches, all dependent on the same water sources. The lakes were filled with Crocodylus thorbjarnarsoni. Deep water provided perfect concealment. Despite its size, despite being larger than a modern car, the predator could remain completely submerged, invisible, then launch ambush attacks using its powerful tail for propulsion, grabbing prey before they registered the threat. The hominins were small. Homo habilis averaged 4 feet tall, perhaps 70 pounds. The size differential is difficult to visualize without comparison. Imagine a modern saltwater crocodile hunting a French bulldog. That's the scale we're discussing. But decades of excavation revealed something unexpected. Despite decades of intensive excavation in the Lake Turkana basin, one of the most productive hominin fossil sites in Africa, not a single hominin bone has been found with Crocodylus thorbjarnarsoni bite marks. Zero direct evidence of predation. This absence troubled researchers. They proposed 2 hypotheses. The first, early hominins were extremely aware of the danger. They avoided water during peak hunting times, dawn, dusk, night, stayed vigilant when drinking, developed survival strategies that minimized risk. The second hypothesis was grimmer. A predator, that massive attacking prey that small, wouldn't necessarily leave evidence. The size differential was so extreme that complete consumption was likely. No bite marks, no scattered remains, just disappearance. But this was speculation. Absence of evidence isn't evidence of absence. Then, researchers found the second giant, and it left proof. At the exact same time, Crocodylus thorbjarnarsoni lived in Lake Turkana. Another massive crocodile inhabited African waterways. Crocodylus anthropophagus. The name is ancient Greek. It means human eater. The species appeared around the time thorbjarnarsoni went extinct, essentially replacing it in the same ecosystem. Similar size, around 25 feet, similar weight, over 2 tons, nearly identical build. But anthropophagus left evidence. Multiple Homo habilis fossils show crocodilian bite marks attributed to this species. Bite marks on leg bones. Forensic analysis suggests ambush attacks from the water, the classic crocodilian hunting pattern. One specimen shows particularly brutal predation. Evidence suggests the individual's leg was forcibly removed by anthropophagus. And then, while still alive, the hominin was attacked by a completely different predator, a large, felid, probably a saber-toothed cat. The fossil record preserves moments, and sometimes those moments are horrifying. Then, researchers noticed a pattern in the data. They began systematically comparing all hominin fossils with crocodile bite marks. They cataloged bite mark dimensions, estimated predator size from tooth spacing and jaw mechanics. Only crocodiles below a certain size threshold left bite marks on hominin bones. Smaller crocodiles, 10 to 15 feet, left clear forensic evidence, bite marks that could be measured, tooth impressions that could be studied, attribution to specific species. Larger crocodiles? Nothing. No bite marks, no tooth impressions, no evidence. The hypothesis: once crocodiles exceeded approximately 20 feet in length, they stopped leaving traces on hominin prey. Not because they stopped hunting hominins, but because the size differential became so extreme that predation left no recoverable evidence. The physics are straightforward. Bite force scales with body mass. A 2.5-ton crocodile generates crushing force exceeding 3,000 pounds per square inches, enough to pulverize bone. When applied to a 70-pound hominin, the mechanical stress would fragment skeletal material beyond recognition, or consume it entirely. Which brings us back to Crocodylus thorbjarnarsoni, the largest crocodile in the system. No bite marks found. Not because it didn't hunt hominins, because it was too efficient. Both thorbjarnarsoni and anthropophagus shared one distinctive feature that separated them from modern crocodiles: horns. Crocodylus thorbjarnarsoni had raised bony rims above its eyes, enlarged prefrontal bones that resembled horns. Modern Nile crocodiles occasionally show this feature, but it's rare. In thorbjarnarsoni, it was standard anatomy. Crocodylus anthropophagus took the adaptation further. Its horns were positioned above the ears instead of the eyes, much more prominent than nearly any crocodile, living or extinct. Distinct enough to earn the species its nickname, the horned crocodile. The horns were especially pronounced in males. Sexual dimorphism. The most likely explanation: territorial displays and mate competition, increasing perceived size during confrontations with rivals. But regardless of function, the horns made these animals look exactly like what they were: apex predators. Lake Turkana supported a third massive crocodilian, Euthecodon brumpti. Size estimates range from 24 to 28 feet, potentially larger than thorbjarnarsoni. But Euthecodon wasn't a threat to hominins. Its jaws were extremely elongated and narrow, convergent evolution with modern gharials. Specialized fish eater. The teeth were slender, pointed, designed for gripping slippery prey, not crushing bone or dismembering mammals. Despite its size, Euthecodon likely couldn't hunt hominins effectively. Wrong anatomy, wrong niche. This is important. Size alone doesn't determine predation patterns. Anatomy does, feeding strategy does. Euthecodon was a specialist. Thorbjarnarsoni and anthropophagus were generalists, capable of taking any prey their size allowed. Lake Turkana during the Pliocene epoch was packed with crocodilian diversity. 3 massive genera, thorbjarnarsoni, anthropophagus, euthycodon, plus the modern Nile crocodile, which still inhabits the lake today in populations exceeding 12,000 individuals. 4 crocodilian species, overlapping territories. How did they coexist? The answer? Specialization. When resources are abundant, when prey is diverse and plentiful, specialists thrive. Each species occupies a distinct niche. Euthycodon takes fish. Nile crocodiles take medium-sized mammals. The giants take megafauna. But when climate fluctuates, specialization becomes vulnerability. And the Pleistocene was defined by rapid climate swings. Around 1.8 million years ago, East Africa's megafauna began declining. Large herbivores, the prey base for giant crocodiles, became scarce. Smaller, generalist crocodiles adapted. The Nile crocodile is a perfect example, capable of eating fish, birds, mammals, carrion, capable of surviving lean times by switching food sources. The giants couldn't make that switch. By 1.8 million years ago, both Crocodylus, thorbjarnarsoni, and anthropophagus were extinct. Both thorbjarnarsoni and anthropophagus appear to have had limited geographic ranges. The fossil evidence comes almost entirely from Lake Turkana and surrounding regions. This wasn't a coincidence. Giant crocodiles face a thermal regulation problem. Body temperature control becomes increasingly difficult as size increases. Surface area to volume ratios work against large reptiles. A 25-foot crocodile requires deep, cool water to prevent overheating. Shallow water doesn't provide adequate temperature buffering. Smaller crocodiles survive in varied habitats, rivers, swamps, seasonal pools. But giants need substantial permanent water. When Pleistocene climate shifts reduced lake levels, the giants had nowhere else to go. Adaptation requires time, evolutionary time, thousands of generations. Climate change happened faster. So what was the largest predator to regularly hunt humans? The answer is Crocodylus thorbjarnarsoni, 25 feet of armored ambush predator, living alongside multiple hominin species for over 3 million years, hunting from the same deep lakes our ancestors depended on for survival. We have no direct bite mark evidence, but the comparison to Crocodylus anthropophagus, a nearly identical predator that did leave forensic traces, confirms the pattern. Once crocodiles exceed a certain size threshold, hominin remains simply disappear, and thorbjarnarsoni was the largest. For 3 million years, our ancestors survived in an environment filled with saber-toothed cats, giant hyenas, and crocodiles that hunted specifically in the one place hominins couldn't avoid: water. Every trip to the lake was risk assessment. Every drink, every fishing attempt, every river crossing. And the largest predator beneath the surface was a 2.5-ton crocodile perfectly adapted to hunt animals our size. Modern saltwater crocodiles kill hundreds of people annually. They're the deadliest large predator to humans when you exclude disease and venom. And they're smaller than Crocodylus thorbjarnarsoni. Our ancestors lived with something worse for millions of years. The fact that we survived is remarkable. Today, crocodiles remain the largest predators in Africa and across tropical regions worldwide. They still hunt humans, they still dominate freshwater ecosystems, but the giants are gone. Crocodylus thorbjarnarsoni, Crocodylus anthropophagus, Euthycodon brumpti, all extinct before modern humans evolved. We never faced them. Homo habilis did, Homo rudolfensis did, Australopithecus did. Every early hominin species in East Africa, between 5 million and 1.8 million years ago, shared their environment with the largest human hunting predators that ever existed, and they survived. Watching the water, staying vigilant, developing the intelligence and caution that would eventually allow their descendants, us, to spread across the planet. Most of Africa's ancient lake systems remain unexcavated. The largest predator to regularly hunt humans is extinct, but its legacy persists in our instincts. The caution we feel near dark water, the wariness of what might be watching from beneath the surface. Because for millions of years, something was.